Hello and welcome to Pre-Calculus 1. We are going to look at using some of the techniques we've learned about factoring as a way to solve a quadratic equation. And there are many ways to solve quadratic equations. There are actually four. We're only going to consider two of them as required for our course, although the notes for the other two are included here. We are going to first look at solving quadratic equations by factoring in this video. And then in another video, we're going to look at solving quadratic equations using the quadratic formula, which is a method that will work for any quadratic equation, even if it can be factored. Not all quadratic equations can be solved by factoring, but if they can, that's generally the easiest technique. So we will start with that. Here are our learning objectives. As I said, we are going to learn how to solve by factoring. And when we learn how to solve by factoring, we will use all of the skills we learned in the factoring unit that we reviewed in the last unit. And then we're also going to learn how to solve using the quadratic formula. I believe many of you have seen the quadratic formula before, but I will consider this in another video. And then we're going to talk about in the quadratic formula what is the discriminant and how can we use that small piece of the quadratic formula to determine the number and types of solutions. By types, I'll mean two real solutions, one repeated solution, or a pair of complex conjugate solutions. And we're going to choose which of these methods is most effective. That's a little more complicated when we're considering all four methods, but you'll quickly determine whether or not you're good enough at factoring to try that when it shows up, or whether you just want to use the quadratic formula. So what is a quadratic equation? It's any second degree polynomial. And when I say second degree, this 2 right here, there's your degree. That's the degree of your polynomial. So a is the number in front of the x squared term, b is the number in front of the x, and c is any constant at the end. The only condition to make this a quadratic is the only one of those three that can't be 0 is a, because if a is 0, you simply have bx plus c, which is no longer a second degree, it's a first degree, and we call that a line. So, moving on. For any second degree polynomial equation, this is a quadratic equation. So here we are in function notation, and here we are just as an equation. When we say we're solving a quadratic equation or finding the roots of a quadratic function, this is what we are solving. We're solving an equation where everything's on one, every term is on one side, and that whole thing is equal to 0. Okay, so what is a quadratic equation? We're talking about finding the zeros. I just said that. So in order to find the zeros, the quadratic equation must be set to 0 because we use a zero factor property. And the zero factor property says that if I have two things that are multiplied, like a, b, if those two things are multiplied together and I know their product is 0, then it has to be true that one of them is 0. The only way to get 0 by multiplying is to have one of the factors be 0. So if I can factor and come up with two factors, so this is like my a and this is like my b. So my choices are either a is 0 or b is 0. So I write that out as a math statement. If I want x minus 3 equal to 0, there's my math statement for that one. I want x plus 2 equals 0. There's my math statement for that one. And then I solve each, and this actually has a typo on it that has lasted for longer than I want to admit. X equals 3 should be the solution to that, and x equals negative 2 is the solution to that. So notice you get two answers often when you solve a quadratic. There is a case where you only get one, that would be if both a and b, the factors were the same. But you get two answers to a second degree equation when you're solving it. You only get one answer to a linear equation. It's important that you find both answers if two different answers exist. So here are the steps for doing this. First, you have to rearrange the equation so one side is 0. So if I'm presented with x squared equals negative 3x minus 2, I can't do anything with that until I move everything to one side and make it equal to 0. This will also be true for when we solve using the quadratic formula. You want one side equal to 0. So you use proper algebra, and I added 3x and added 2 to both sides to make the right side become 0. Then you factor. Now, of course, this only works if the equation factors. If it doesn't factor, you'll use the quadratic formula. So you factor x squared plus 3x plus 2, and you get x plus 2 times x plus 1 equals 0. Now, this means here is my a, either this is 0 or this is 0. So I write each equal to 0. There's one equation to solve, and here's my second equation to solve. So in the first one, I get x equals negative 2, and when I solve the second one, I get x equals negative 1. So the solutions to x squared equals negative 3x minus 2 are x equals negative 2, x equals negative 1. Now we can check those by placing them back into the equation. So what if I do negative 2 squared equals negative 3 times negative 2 minus 1. I'm sorry, negative 3 minus 2 minus, that should be a 2. There we go. So I check the arithmetic. Now in your calculator, make sure you put this in parentheses, because if you don't put the negative 2 in parentheses, it will square the 2 and then apply the times negative 1. You want negative 2 times itself. So this is 4 equals 6 minus 2, and that indeed is true. I could find that negative 1 also makes this equation true. I would get 1 equals 1. So that's the way you check to see if your equations work, if your solutions work. Another example, why don't you try this one? Stop the video. The hint is you have to make one side be 0. And then the factoring is a little trickier in this one. So you stop the video and try this one, and then come back and we'll see how you did. All right, I'm trusting you stopped the video. Only you know if you did or not. And here is what the solutions to this one look like. So first I move the 8 to the other side to make one side 0. And then I factor. Now getting that factoring may have been tricky. So if you want a reminder of how you could factor that one using the grouping method, you could do this. You could do 3 times negative 8 is negative 24. And now you want the factors of negative 24 that will add up to the number in the middle, which is negative 2. So I see a negative 6 times a 4 pretty quickly. And then some of us like to draw boxes and split up our polynomial into boxes. So it's 3x squared. And I'm going to, instead of writing minus 2x in one of the boxes, I'm going to recreate that as negative 6x plus 4x. Because that is equivalent to negative 2x, I'm allowed to do that. And I need a negative 8 there. Now, at the top of each column, I look for a common factor in the column. And here I see I have a common factor of x in this column. And here I have a common factor, since this first one's negative, I make it a negative 2. And then I look across the rows, and I see 3x squared, negative 6x. I have a 3x as a common factor there. 4x minus 8, I have a 4, and that's a positive 4 because the leading box is positive, and that gives me my two factors. So if you've forgotten how to do that or never really understood it, there's another shot at looking at that. Okay, so then I go on and I solve. I set 3x plus 4 equal to 0 and x minus 2 equal to 0 to get my two solutions. There are the two equations I now solve. It's easy to solve a linear equation. This always comes down to that when you're solving a quadratic by factoring. And you're going to do this with degrees higher than 2. You always come down to setting a factor equal to 0 and finding that solution. So I get x equals negative 4/3 and x equals 2. And I could plug those back in, properly squaring negative 4/3. Being careful to do that, and find that they do solve my original equation. They make it true. Okay, so that is all we have to do with factoring. So try a couple of those. They're in your homework. The hardest part may be the factoring. I will do another one over here as an example. So let's try this one. Start over. Let's solve x squared equals 4. Now some of you are going, oh, I get 2. Well, don't forget you get 2 and negative 2. And here's another reinforcement of why you get 2 answers there. Because if I decide I want to solve this one by factoring, by the way, when you just say it's 2 and negative 2, you're using the square root property. All right, let me fix that. Okay, so x squared minus 4 equals 0 is what you always do when you're solving by factoring or by the quadratic formula. This factors to x plus 2 times x minus 2, and that's still equal to 0. So the two choices are either x plus 2 equals 0 or x minus 2 equals 0, and that gives me x equals negative 2, x equals positive 2. I get 2 answers this way, therefore I should get 2 answers if I just simply take the square root of both sides. And when you take the square root of both sides like that, write a plus and minus in front of the numerical side. Okay, so there's one more example. You have homework associated with this, and let me know as you have questions. Thank you for joining me for this edition of Math Teacher to Go. See you in class.